Welcome to this guided tour of SpaceStudio, a development environment that eases the design flow of C++ application for multiprocessor system-on-chip coupled with a FPGA fabric while providing system-level optimization. My name is Hubert and I will present some of the functionality of SpaceStudio like simulation, FPGA estimation, and complete system generation for final execution on a FPGA board. First off, when starting SpaceStudio, we are presented with a welcome page with quick actions. Let's open the producer consumer application which I have previously created. The Project Explorer displays the content of the project where the application components represent your application. For this project, the application is a simple producer consumer application, but it can be a more complex such as a GNSS receiver with multiple application IPs. A typical application IP will read, compute, and write data backs for the next IP. In this project, there are currently two architectures like the MicroBlaze architecture. An architecture is a description of a system with platform IPs such as a timer, interrupt controller, and processor where your application is mapped as hardware accelerator or software threads. Some IP may reveal other IP as shown by the MicroBlaze SoC. The red color indicates that the application IP is mapped as hardware accelerator. The blue color indicates automatically instantiated platform IP by SpaceStudio. And finally, the green color indicates that the IP can accept software tasks. So now, let's create a new architecture with the Zinc SoC from scratch. From this empty diagram, I simply drag and drop IP from the right pane onto the diagram without worrying about the connection as SpaceStudio will fill in the gap. When the mapping of my application is completed, I can let SpaceStudio generate the virtual platform for me by clicking on Generate. When generating, SpaceStudio will analyze the application source code and will generate the virtual platform tailored to the mapping of this application. SpaceStudio goes the extra mile so you can focus on developing your application. Anytime you change the architecture, just click Generate and let SpaceStudio do the rest. Now we click on Build to compile the virtual platform. Then we click on Play to execute the simulation. SpaceStudio comes with several ready-to-use processor models and operating system. In this example, the ARM Cortex-A9 is executing the Linux operating system. As requested by the source code of the application, the simulation ends automatically once the consumer has received a certain amount of data. For this architecture, we can ask SpaceStudio to estimate the FPGA resource utilization by clicking Tools, FPGA Resource Estimation, make the appropriate selection, then click OK. At this point, SpaceStudio is invoking the EDA and HLS tools, in this case Vivado and Vivado HLS, to estimate the FPGA resources for each IP in the architecture. The result is displayed at the end of the process and indicates that the architectures can be implemented on the FPGA. You can click on the Details button to display the FPGA resources estimation for each IP. Finally, we can ask SpaceStudio to generate the full system for final execution on a FPGA board. To do so, click on Tools, Architectures Implementation, make the appropriate selection, then click OK. At this point, SpaceStudio is automating the complete generation process for you. Just sit back and wait for the result. Once the process is complete, you just need to copy the ready-made files to an SD card to start your application on the FPGA board. That concludes this video and thank you for watching this guided tour of SpaceStudio. To find out more, contact us at spacecodesign.com.